In this video, I'm going to replace my rotor bolts. This brake rotor is completely detached. I was riding the bike and I put on the brakes and all 6 of the rotor bolts snapped. This bike has a long spacer, it's 16 millimeters long, and I think the bolts might not have been the best quality bolts. So as you can see right now, this rotor is freely spinning. So I have no rear brakes right now. So I'm going to remove the broken rotor bolts and put in high quality rotor bolts. Here's a view of what I have here. This brake rotor is completely detached. All 6 of the bolts sheared and failed. This is an e-bike, so I had to disconnect the wiring that goes to the rear hub motor. Here you see the temp sensor wire for the motor temperature sensor, the 3 motor wires, the Hall sensor connector, and the battery. I also need to remove the torque plate and the axle nuts. There's a torque plate on both sides. This torque plate is a 1/4 inch thick. It happens to be 303 stainless, and it's used to prevent the axle from twisting in the frame, either under forward power or regenerative braking power, because I've actually had motor axles twist in the frame and crack the frame. So I'll be taking off the torque plates and the axle nuts. I want to make note here that on this bike, I have some brass thrust washers right here that I bought at the hardware store. They're 5/8 because this axle is M16. So you can get 5/8 brass thrust washers to space your cassette from your frame so that the cassette doesn't rub. So there's 2 brass thrust washers right here. So when I remove a rear wheel, I always put the drivetrain in the tallest gear so I know where to put it back to when I put the wheel back on. And I like to just remove the chain. It makes it easier. When I remove a chain, I use these Masterlink pliers and this chain tool, which I found makes it a lot easier. So what I do is I get the chain up, get some room in the chain, and now I'm free to work on the Masterlink. This is a SRAM chain, so this is called a power link. And then just take it apart like that, and then set these aside. These are the power links. And then I'll take off the chain. Makes it easier to remove the wheel and put the wheel back on if you don't have a chain involved. So I found an easy way to set the hub motor on the workbench. I made this box out of thick ABS and I drilled a hole in it, and I used painter's tape so that when I put the freewheel or the brake side of the hub motor on the bench, it doesn't damage it and it sits flat on the bench. Here we see a close-up view of the carnage. You have 6 sheared rotor bolts here on this flange. This flange looks like this, and I have a few extras, but what I'm going to do is remove the flange and remove each of these sheared bolts so that I can reuse this flange. This flange bolts to the side cover with its own bolts, and then the rotor mounts on that 6-bolt pattern. The flange bolts to the side cover with these M5 bolts. So the brake rotor flange didn't want to come off for whatever reason, so I installed a gear puller onto the hub motor flange. And because when I turn this, it can turn the axle, I clamped the bicycle axle in a bench vise. And as I tighten this, I'm going to hammer in the teeth a little bit. So I hope this works. Also note that I put a couple of cable ties here to keep the gear puller tight. So now the brake rotor flange has come off with almost no damage to the end of my axle. This axle's tough. So the gear puller worked and I got this off, and the bolts were extending down a lot and they were not really threaded into the brake side cover, but that's why it was fused, because these bolts were grabbing onto the side cover here. So I'm going to take a close-up video of what we have here. So this is the situation I have after using the gear puller. Those surfaces will need to be made flat. It looks like there was some spray paint on there, so maybe that was helping it fuse. And if you look here at the side cover, you can see how the rotor bolts were wedged into there. And then here's the top of the axle where the gear puller sort of dug in there a little bit. I don't have a problem with that. I'll show you what an axle looks like that hasn't had a gear puller wrenched on it. Here's the side of an axle that has never had a gear puller wrenched on it. So you can see the gear puller didn't do hardly any damage to the side of the axle. Here's a view of what it looks like after I cleaned it up. You could see where the bolts that broke were wedged into the motor side cover. So what I've done now is I've removed the brake rotor flange and I have it in the soft jaws of the vise, and I'm going to use these exposed shanks to pull out the broken bolts. So I'll work on this one first. It's got a pretty long surface. My first attempt will be to grab it with these pliers. And I'm trying to pull out the shank. It's coming very easily. So get a good tight grip on it. It's just a question of turning the right way. And this is real easy money. I could probably almost pull that out with my finger. So only 5 more to go if I can get this one out. So this benefits me that the shanks were sticking out. See if I can do it with my finger. Yep, it's so easy to do, I can do it with my finger. So there's the shank that was stuck in there. This one is slightly shorter. See if I can grab it. Push down as much as I can. Grab it tight. I didn't get any oil in there. Oil them all. This is household 3-in-1 oil. Here I'm grabbing another one. I'm pulling out the shanks that broke off in the brake rotor flange. I'm having a hard time getting a grip on this one. There, I've got a grip on it. The oil is good for lubricating, but it's not good for helping me get a grip. I need to get a tight grip. Using the exposed shanks to unthread the piece of bolt that's trapped in there. Now I got it. I can feel it coming. You can definitely feel it unthreading. So that, once it comes pretty easily. Coming very nicely. Just threads right out. Maybe even do it with my finger. Yep, can even do it with my finger. So there's the broken shank. So that last one got stuck. So now I'm starting on another one. I've oiled it up pretty good. So let's see if this one wants to come out. This one is cooperating. have to put a lot of pressure on the pliers. At some point I might put oil on the other side. It's always nice when you get a stripped bolt and you can have an exposed shank and just pull that out. If you can. I had thought maybe I was going to have to drill out all 6 of these, so I'll take what I can get here. I could also put the bolt in the vise and turn the flange, get more leverage. Let's see if this one's coming. This one has stopped coming. So it gets to a certain point. No, this one's good. This is hard work. Having to fight for every little bit of progress. This one's almost out. And get some oil on the other side. So I've noticed I can get a lot more leverage if I put the exposed shank in the bench vise. It's real easy to turn. I get that extra leverage. I've got a shank sticking out that's in the way over there, but this is real easy to pull it out. I would imagine at this point I could just thread it out by hand. Yep, this one's coming out easily, so that one's out. Here's the other one that was giving me trouble. My dad is here and he suggested that I could take my hacksaw and cut a slot and use a screwdriver to get it out. So we're gonna try that also. This one will be easier because I don't have an exposed shank in the way. So what I do is I put the exposed shank in the vise, and when I turn like this, I get a lot of leverage. Those other shanks are sticking out a little bit, so I guess I'm going to have to do a series of these moves here. Put in the shank, turn it, loosen, put in the shank, turn it. There's little shanks in there that are getting in my way. This would only apply if if the shank is sticking out far enough to be clamped by the bench vise. At this point, I might be able to lift it up higher than the shanks that are sticking out, and then just, well, that's easy money right there. So now I'm starting a new one that I haven't worked on yet. So I'll make sure it has oil. Just oil them both now. Let the oil get in there and work a little. So I've got a little bit of an exposed shank that I may or may not be able to clamp in the drill in the bench vise. So there I am pushing down, tighten the bench vise, and under these circumstances I have a tremendous amount of leverage. So this is the way to do it. Because you get so much leverage with the length here. Okay, so push down, clamp the shank, turn until something gets in my way. Keep repeating that process. At this point, I may be able to thread it out by hand. Which is faster than that vise operation. Here I am using needle nose pliers to thread it out by hand. That shank gets in the way no matter what you do. But this is coming out very easily. I'm going to give the credit to the oil. Maybe I could, no, I thought I could do it by hand, but anyway, that's the end of that one. Now this one will be good because nothing will be in my way. So I've got one last bolt in there that was sheared. Here's the last one. I have a bolt here that was sheared off, and it's sticking out enough to where I have some room to work here. So I take that exposed shank and clamp it in the drill, in the bench vise, and turn away. That's what they call easy money. All that leverage with the big brake rotor. So I'm going to clean this up and find some quality bolts with a good length. Hopefully this won't happen again. Here I am taking out the head of the bolts. This is one I just removed. You can see where it's sheared. I got this on eBay. It might not be the highest quality bolt. It's a very long bolt for what I'm having it do. Look how long the rotor spacer is. It's a lot of rotor spacing. It's a total of 16 or 16.5 millimeters. So these are coming out easily. Very straightforward. 6 sheared bolts. So now I was even having a little bit of trouble pulling out the remaining bolts, even though I have a Torx that I can get on there. What's happening is I'm turning and I'm feeling the threads in here on that bottom spacer, because the bottom spacer has 2.5 millimeters of threads. And once I clear those threads, the bolt will just pull out because this large rotor spacer doesn't have any threads in it. So all I have to do is clear the threads on this 2.5 millimeter spacer. And even though I've cleared the threads, it's not wanting to come. So I don't know if I think the bolt might be a little bent. Here I am twisting and pulling with my fingers. I can't get a grip, so I'm gonna grab onto it with some needle nose pliers, grip it real tight, twist, and I'm pulling as I twist because I suspect that the bolt is bent. Wonder why it wasn't coming. Can't imagine what it's latched onto. Here now it's all wedged in there. It was some remaining Loctite that was hanging me up. So these remaining bolts, I would have thought it would have been easy just to thread them right out. There's threads on this 2.5 millimeter rotor spacer, but there are no threads in this larger 15 millimeter rotor spacer. So what's happening here is when I'm loosening the bolt, it's coming out of those threads. This one looks like it's coming out easily. Let me see if I can grab it with my fingers. That one came out very easily. See about this one here. There was some Loctite that was in there gumming it up a little bit, so this comes out. So what I have here is my long rotor spacer, which was causing the problem because there's so much rotor spacing involved. I have 15 millimeters plus 2.5 millimeters plus 3 of these 0.5 millimeter ones. 1, 2, 3, 4. It's 2 millimeters, 4.5. It looks like it's 19.5 millimeters of rotor spacing, which is a big task for an M5 bolt. Here's the bolts that failed. You can see they sheared right off, all 6 of them. And I'm questioning the quality of the bolts. I bought these on eBay. And I'm going to try some bolts with a known grade. So now I'm ready to pick out some quality bolts. So I ended up finding some grade 12.9 bolts. These are M5 with a 30 millimeter shank. And I think grade 12.9 will hold up to the task. When I do a test install with all my rotor spacers in place, it sticks through just a little, but I know there's room there in the side cover that got hogged out from the bolts before. So I think this won't happen to me again when I reinstall these. So here I am installing the brake rotor flange. I put it over the wiring harness and then fit it over here. The bolts that I'm using, these are M5, the low profile, and they take a 3 millimeter hex key. I don't use Loctite here. Never had a problem. Here's the final tightening on these, what you would call a brake rotor flange. Definitely not overdoing it here. I strip these bolts, I'm in trouble. These are really small keys here, 3 millimeters, so you make sure it's in all the way. So that was what I would call a preliminary final tightening. And now with this tightening, I'm just going around and making sure that they're all tight enough. Here I am here, bending the hex key just a little bit. Go to the other side, keep track of where I was. That's enough. Come across to the other side. So I'm putting it all back together now. And I put it through the bolts. I put in my large rotor spacer. And this one has threads in it, so I'm having to thread this to thread in that 2.5 millimeter rotor spacer. Get it all nice and flush. And now I've put on the 4 half millimeter spacers. Now I'm going to put on a small amount of blue Loctite. So now I've got a small amount of blue Loctite on there. And I'm definitely 100% going to look up the torque spec for this application. I always take the time to look up a torque spec, which is easy to do on Google, and use a torque wrench. It takes a little bit, could save someone's life. Let's see how I do starting these bolts. Here I'm just careful to start the bolts, and I'm always careful not to cross thread anything, and definitely doing it in a sequence. So here I am using a torque wrench to torque everything to 4 Newton meters. That one's done. Go across the other side, that one's done. Go across to one I haven't done on the other side. There's some slack to take up because of the rotor spacers. That one's there. So this isn't very tight. That one's at spec. This one has a lot of slack to take up because the rotor spacers. So that one's there. I want to do this right-handed. I'm right-handed. I want to be consistent here. Okay, so everything's at 4 Newton meters, which I'll just double check. Because like I say, I ride this bike really fast on busy roads. I don't want to get killed. Okay, good. Good. Okay, so these are all torqued to spec now, and the blue Loctite is in there. Note that I cleaned the rotor with alcohol. Keep all the oil off there. So now I'm going to reinstall everything. So the last scene in this video is going to be where I show you how I deal with these pads when I'm working on the bike. When I'm working on the bike, I always put in these pad spreaders, which is a plastic part which comes with, in this case, hydraulic brakes. And when you're working on the bike, make sure these are in there while you're working on the bike, because you'd be surprised how often when you're working on a bike, somebody comes along and grabs the rear brake lever. I've actually had that happen to me. And then the final thing is this tool here, which, well, this is called a pad spacer. Pad spacer, brake pad spacer. This is called a brake pad spreader. And you always want to use one of these before you put your brakes back together. What you do is you stick it in here and you do shove, get it all the way in there, and that'll set the right spacing. Makes it easier to set up the brakes. Thanks for watching.